Alright, so guys, remember, whenever we graph, we're going to always start with, if all else fails, make an XY chart. So if you're not sure what to do, the first thing you should do is make an XY chart. You could just pick random points here if you want. You could pick whatever you want. I am not going to do that. Alright, you could pick whatever points you want for X. You could put those numbers in there, plug it in, and that's how you're going to get your Y's. Alright, now I know that this is called an exponential function. Alright, so since X is in the exponent, this is called an exponential function. Alright, it's either going to get really big really fast or really small really fast. Okay, so it's either going to have exponential growth where it gets really big, or exponential decay where it gets really small. Keyword, growth and decay. The keywords are growth and decay. So exponential functions could be growth, which means it's going to get really big really fast, and that's just not a good way to draw that. I'm just not very neat with that. And that would be like your XY chart right there. So the red line would be the graph, or it could be decay. And that would get really small really fast. It would start big and get really small. That's probably not big either. Yeah, it's a little better. That's not. Because usually, unless there's the decay, would kind of look like that. Alright, we're going to talk about some exponential functions have things called asymptotes. So that's another idea that's kind of new here. So asymptotes are like a point on the graph that it's like an imaginary line that the graph cannot cross. So like in a normal, just a regular everyday asymptote, and like I said guys, they're not really part of the graph, that's why they're usually dotted. I don't know how that looks. So like the asymptotes would kind of look like this. Right? That purple line is a line that that graph can't cross. Now, the function of an exponential function usually looks like this. So it usually looks like y equals a b to the x. Right? A is just like every a we've done. It makes it skinnier, fatter, things like that. It makes it negative, like it flips it and stuff like that. So a is just like that. Now we also have h and k still. And remember, h is still dirty and k is still cool. The only difference between, remember, we're not going to call this h and k is not a vertex. Alright, no vertex. We're going to call it a starting point. And the starting point normally is not h and k. It's actually going to be h, and this time it's k plus 1. That's the main difference between exponential form, is when you find k, you add 1 to it. Alright, so that's the main difference between anything that we've seen before. So, like I said, if all else failed, you could have just made an XY chart right away, and it would have been totally fine. Probably would have worked out for the most part. But really, mathematically, the first thing you should do is you should identify that this is going to be a growth problem. And the reason it's growth is because a is greater, or not a, b is greater than 1. All right? That's why it's going to be growth. All right? So I know it's growth, so I know my graph should be getting bigger. So I already know it's growth. The next thing you should do is find h and k. So h is positive 2. K is positive 3. Remember, it's a dirty h, right? So even though it looks like negative 2, we don't trust it. Remember, k is cool, so we trust him. right? Remember dirty h hanging out with your x. So now my starting point right here is going to be 2, but instead of 3, I do 3 plus 1 to give me 4. Alright, so that's my starting point, is 2, 4. So 2, 4, and that's like this. That's like where the graph like kind of changes and starts to go up really, really quick. So I go over 2, up 4, and I put a dot. Right? That's my starting point. Now, K itself is also the asymptote. So I know that my graph is never going to go below 3. Right? That's another thing that's important to know, is that K is also the asymptote, or like y equals 3 is the asymptote. Right? So I know that. Right? Remember, your graph, it will go up because it's growth, but it will never cross that little purple line. Right? Now, I'm just going to pick some points. We'll say 3, 4. If you want to pick 1 and 0, that's fine. It doesn't really matter. You're just going to plug them in. So normally I'd just go pick like 3 points for this one, but you could pick 5 if you want. If you want to put 1 in the middle and go 0, 1, 2, 3, 4, that's fine. So I plug in 3 minus, so I plug in 3 right here. So I'm plugging in 3 right here. So I get 2 to the 3 minus 2 to the 3 minus 2 plus 3. So 3 minus 2 is 1. 2 to the first is 2. 2 plus 3 is 5. Right? Now I'm going to do 4. So I get 2 to the 4 minus 2 plus 3. So 2 squared is 4. 4 plus 3 is 7. Right? Sometimes people don't feel like that's getting up enough. So what we'll do is I'll even pick some more points. Maybe you don't feel comfortable. Maybe this doesn't feel like enough points for you. So we'll pick 5. Right? And then I'll say 2 to the 5 minus 2 is 3. So 2 cubed is 8. 8 plus 3 is 11. If you want to put 6 on there, so then I get 2 to the 6 minus 2. So 2 to the 4th is 16. It's 19. See, I notice it's getting really big really quick. So 3, 5. So I go over 3, 5. 4, 7. 4 goes up to 7. And then I know it's going to be shoot up to 11. Some people sometimes want to pick like 1 and 0 because they want to go both sides. So you want to pick 1, you'd say 2 to the 1 minus 2 plus 3. Remember, 2 to the negative first. Remember, negative exponent. Means a fraction answer. So it's actually 1/2 plus 3, which is 3.5. And you can plug it in your calculator if you weren't sure how that happened. So you could always put 3.5. And then 0, I get 2 to the 0 minus 2. So that's 1 over 2 squared, because remember the negative exponent goes down and lives in the basement. So I get 3.25. So I get 3.5, 3.25. I notice it's going there, and guys, it's never going to pass 3. Alright? It's never going to, so my graph, when I go, it's going to kind of look like this. And really, it should go up a little bit faster than that. We already know that it's going to go. So I didn't do a very good job with the, that's pretty good. Alright? And that's it. So, just to recap, notice a kind of new concept. Determine if it's growth or decay. This one, growth, is any time that the number with the x is bigger than 1. 2 is bigger than 1. Growth. Okay? Then, find h and k. H, k. First point. Remember, for this one, your starting point, you're going to add 1 to the k. K is going to be your asymptote. Alright, there's my asymptote. Plug it in, graph it. Done. Alright, number 2. Once again, this is an exponential function. It is decay, since this number right here is between 0 and 1. It's a fraction. So decay, since we're going to say b, is between 0 and 1. Alright? That means I know my graph is going to start up and go down. Alright? So, decay. Step 2. We know it's decay. Now I want to know if h and k. H is -1. Remember, that's your H, and it's a dirty H. K is -2. He's cool. Right? Remember, my asymptote is going to be at the line y equals -2. So I'm going to go down to -2 and put a dotted line. That is not part of the graph. It's just telling you that your graph can, that's why it's dotted, your graph cannot go any lower than that. Or, yeah, any lower than that. If it was flipped, like if there was like a negative number right there, then it would not be able to go higher than that. So now I'm going to make my XY chart. Like I said, some people want number. Some people will pick like -2, or -3, -2, -1, 0, 1, 2. You can pick as many points as you want. We know that H and K, so this is your H. So K is actually going to be -1 because it's -2 plus 1. And if you're not sure if that's going to be -1, just plug it in. Put -1 right there. -1 plus 1 is 0. 1/3 to the 0 is 1. 1 minus 2 is -1. So it's true. All right. Now I'm going to plug in 0. 0 plus 1, so I get 1/3 minus 2. That's -1 and a sixth. -1 and 2/6. I'm sorry. Or 2/3. I don't know what I'm thinking. So, if I plug in, I get 1/3 to the 0 plus 1 minus 2. So I get 1/3, because it's 1/3 to the first power, minus 2, it's -1.66. Alright? Now I'm going to plug in 1. Alright? 1, I get 1/3 squared minus 2. 1/3 squared is 9. 1/9. 1/9 minus 2 is -1.8. And I'm not even going to plug in 2 because I know it's going to be close to 2. Now I'm going to plug in -2. So 1/3 to the -2, so it's -2 plus 1 minus 2. So -2 plus 1, so it's 1/3 to the -1, which is 3. 3 minus 2 is 1. Now I'm going to plug in 1/3 to the -3 plus 1. So it's 1/3 to the -2, which is actually the same thing as 3 squared, which is 9. 9 minus 2 is 7. So I got my points. I'm going to go -3. So my starting point, -1, -1. That's my starting point. Starting point. Okay. Then I go 0, -1 and 2/3. Right. -3 goes up to 7, and this is getting really big really fast, right, which is what happens with a... Now, see at the end, I can't let that graph cross the purple line. And that's it. That's a Firestarter 26. Exponential growth and decay. Like I said, worst case scenario, plug and chug. Pick points, plug them in, use your calculator.